How will the end of the universe be? Here are 5 theories to explain it. We consider everything that has a beginning to also have an end. Today we understand that the universe began with the Big Bang, consequently it must also reach a conclusion. However, what will that conclusion entail? When will this occur? What will occur upon the demise of the universe? Keep watching to find out. Hello everyone, welcome back to Zeey. Subscribe to our channel and ring the bell so you don't miss any of our daily videos. Ever since the human race became cognizant of its own existence, it has also prompted us to inquire into numerous matters pertaining to our mortality. From where did we originate? To where shall we proceed? How did everything begin? Furthermore, how will it conclude? These are some of the inquiries that have long been debated. However, with the progress of science and technology, we may now have definitive answers to those questions for the first time in history. We have determined the manner in which the universe evolves and how it might come to an end through observation. We then list the 5 most widely accepted theories that account for the universe's demise. Number 1. Big Freeze. Freeze death or the Big Freeze theory is among the most widely acknowledged hypotheses regarding the ultimate destiny of the universe. This theory posits that the universe is undergoing an ever-increasing rate of expansion and will eventually decrease to near absolute zero, precipitating the eradication of all life and matter. The second law of thermodynamics, which states that the entropy of a confined system increases with time, is the foundation for this theory. Entropy denotes the degree of disorder present in a given system. In accordance with this principle, the degree of disorder in the universe will perpetually escalate over time. As the universe undergoes expansion, the available energy becomes more diffuse, leading to a reduction in entropy. This indicates that the universe is undergoing a process of cooling. Ultimately, the temperature will reach absolute zero as all energy is dispersed. According to the Big Freeze theory, the expansion of the universe will persist indefinitely, accompanied by a reduction in the density of matter and energy. As time passes, the stars will deplete their propellant and undergo combustion, resulting in the formation of a frigid and obscuring cosmos. Isolated subatomic particles and the elementary particles that comprise the universe will be the only things that endure. It is noteworthy that the Big Freeze theory also carries significance for the theory of biological evolution, as it posits that the time remaining for life to evolve in the universe is finite, prior to its eventual cooling and demise. This implies that life is a transient and uncommon occurrence, with a limited opportunity to endure within the vast expanse of cosmic time. While the Big Freeze theory may appear pessimistic, it also encourages us to value existence and life as we presently understand them. Number 2. Big Crunch. The Big Crunch theory regarding the conclusion of the universe is among the most intriguing hypotheses. This theory posits that the universe possesses a limit rather than being infinite. Moreover, he posits that the present expansion of the universe, which is presently being observed, will ultimately cease, leading to a contraction that will reach its zenith at a moment of complete collapse. Dark energy is responsible for the universe's perpetual expansion according to this theory. However, gravity will ultimately begin to contract the universe as its force of contraction is overcome. The universe will experience a substantial increase in density and temperature as it undergoes compression. Over time, the entirety of the universe will disintegrate into a singularity, which is a point of infinite temperature and density. This collapse of the universe is comparable to the Big Bang, however it will result in its destruction rather than a massive detonation that formed the universe. An analogous Big Bounce to a reversal of the Big Bang, the Big Crunch signifies the end of one epoch and the start of another. The Big Crunch was initially postulated by theorists such as Roger Penrose and Stephen Hawking during the 1960s and 1970s. While this theory has been posited as a potential pathway towards the cessation of the universe, its actuality remains uncertain. The most persuasive proof for the Big Crunch is derived from the investigation of the density of the universe. Einstein's theory of general relativity posits that the geometry and destiny of the universe are predetermined by its density. The contraction of the universe will occur if its density surpasses a specific critical value. Constant expansion of the universe will ensue indefinitely if its density falls below the critical value. When the density of the universe reaches the critical value, its expansion will continue indefinitely at an ever-decelerating rate. By analyzing cosmic background radiation, astronomers have been able to approximate the density of the universe. Despite substantial uncertainty remaining in these calculations, the most recent measurements indicate that the density of the universe is approaching the critical value, thereby implying a potential fate of collapse for the universe. Three, Big Chill. The third theory regarding the destiny of the universe is the Big Chill theory, also known as eternal expansion. According to this hypothesis, the universe will undergo an infinite expansion while gradually decreasing in temperature, culminating in a state where it approaches absolute zero. The theory is founded upon the empirical observation of the universe's perpetual expansion. The phenomenon under consideration is postulated to be dark energy, an energy type that seems to be hastening the rate of expansion of the universe. Dark energy, an enigmatic phenomenon that remains largely unexplored in scientific circles, is estimated to comprise around 68% of the universe's total energy. As the universe continues to expand, the Big Chill theory predicts that the density of matter and energy will continue to decrease, resulting in an increasing reduction in particle collisions and interactions. Consequently, the temperature of the universe will diminish as well, given the relationship between temperature and the kinetic and momentum energies of particles. Over time, the universe will attain a state of thermodynamic equilibrium, wherein the temperature is uniform across the entire universe and all matter is uniformly distributed, as postulated by this theory. At this juncture, the temperature of the universe will approach absolute zero, signifying the lowest conceivable level, and all chemical and physical reactions will cease. This ultimate condition is referred to as thermal death and is one of the potential cessations of the universe. Despite the fact that eternal expansion appears to be a plausible possibility for the future of the universe, it remains a contentious theory. Certain scientists posit that the quantity of dark energy might fluctuate and potentially diminish in the future, thereby potentially influencing the expansion of the universe. There are those who propose the existence of unidentified phenomena that might alter the expansion of the universe. Number 4. Big Rip. According to this theory, the expansion of the universe will persist. However, it is anticipated that eventually the rate of expansion will reach an extent beyond which gravitational pull will be able to sustain the most massive objects in the universe, including galaxies and stars. This will lead to the complete annihilation of all entities present in the cosmos, encompassing matter, energy, and the fundamental structure of spacetime. This would result in the universe disintegrating, hence the moniker Big Rip theory. This theory posits that dark energy, which is the same enigmatic force responsible for the accelerating expansion of the universe, intensifies in magnitude with its expansion. With the increase in strength of dark energy, its influence on space and matter becomes more pronounced, thereby propelling the expansion of the universe to unprecedented levels. According to the Big Rip theory, dark energy will eventually be so powerful that it will surpass the gravitational force in the universe, resulting in the fragmentation of all cosmic structures. This would comprise the subatomic particles that constitute all matter in the universe, in addition to galaxies and stars. Although this theory may appear to be quite ominous, much remains unknown regarding dark energy and its effect on the expansion of the universe. Scholars are diligently striving to enhance their comprehension of this enigmatic force and the potential ramifications it might have on the trajectory of the cosmos. Similar to other hypotheses, the Big Rip has its detractors. Certain scientists contend that the expansion of dark energy is not an inevitable one, rather, it may experience periods of diminishment or cessation. There are those who think that unidentified forces might be capable of impeding the expansion of the universe and preventing it from disintegrating. Number 5. Cyclical Universe. The cyclic universe theory, alternatively referred to as the oscillating universe theory, posits that the universe undergoes expansion and contraction in an infinite cycle. The universe expands for billions of years before reaching its maximum and then contracting once more, according to this theory. At a sufficiently small dimension, the universe condenses into a singularity, which is an infinitesimally small point. It then undergoes a massive detonation known as the Big Bang, which initiates a new cycle of expansion. As per this theoretical framework, the universe is said to have existed and will continue to exist indefinitely, devoid of a distinct beginning or end. Contrary to the proposed singularity, a sequence of expansion and contraction cycles would have transpired, commencing with a Big Bang and concluding with a contraction would have comprised the Big Bang. Thus, the Big Bang signified the cessation of the prior universe and the commencement of the current universe. A significant body of evidence in favor of this theory is the identification of cosmic background radiation, an irradiant radiance that has been detected across the universe and is hypothesized to originate from the Big Bang. This cosmic background radiation is evidence, according to the theory of the cyclical universe, that the universe has undergone cycles of expansion and contraction. During the contraction phase, the radiation would have cooled and dispersed into space. Nevertheless, the cyclic universe theory lacks widespread acceptance. Certain scientists contend that the available observational evidence is inadequate to substantiate the concept of a cyclical universe. Furthermore, they contend that this theory fails to account for specific cosmological phenomena, including the recently observed acceleration of the universe's expansion. Moreover, this theory gives rise to the inquiry of whether the information that comprises the universe can remain unchanged during every contraction and expansion cycle. If the universe is doomed to perpetual repetition, then the progressive increase in complexity within it over time cannot be rationalized. Notwithstanding these constraints, the cyclical universe theory continues to be an intriguing postulation that sustains its relevance in scientific discourse and investigation. The precise trajectory of the universe's future remains enigmatic, necessitating additional investigation and exploration to unveil its secrets. Upon careful consideration of the various proposed theories concerning the ultimate destiny of the universe, one is confronted with a spectrum of potential outcomes that span from perpetual expansion to the ultimate extinction of the universe. All of these theories posit that the universe is in a constant state of evolution and change, prompting us to contemplate our own existence. Reflecting on the end of the universe serves as a reminder that, despite the fact that nothing in this universe is eternal, not even the universe itself, we will all perish sooner or later. By contemplating our eventual mortality, we can discover the drive to strive for a constructive legacy and maximize our time on Earth. In essence, the investigation into the prospective trajectory of the cosmos encourages us to ponder the most fundamental inquiries pertaining to the human condition and our position within it. It serves as a reminder that life is ephemeral and valuable, and that we must collaborate to safeguard and preserve life in its entirety. May this understanding motivate us to further investigate the cosmos and uncover the enigmatic phenomena that persist until the end of time. And you, how do you imagine the end of the universe will be? Please share your thoughts in the comments section below. Thanks for watching and see you in the next video.